Question 13. Amy has to visit towns B and C from her town A. So Amy stays over there. And she's going to visit towns B and town C. Now this picture shows the roads connecting the three towns. How many different routes can she take if she starts and she ends at A? She's got to go through B and C once only, and she cannot travel on any road twice on the same trip. So let's have a look and see what we're not allowed to do. We can go from A to C to B, but you can't come back on this road because that would mean passing through C a second time. So that's not allowed. And the other thing is, if you travelled from A to C and then to B, and then you started travelling back along the same road back to C, not allowed to do that. Those two. Right, here's a possible route. We could go from A to C, C to B, and then back along the top road back to A. That would work, we wouldn't break any rules. And we could also do the same route in reverse. We could go from A to B, B to C, and C back to A. So those two possible routes. Let's look at them in groups of 4. On our first one, we are going around the top road to B. And on this one, we're also going around the top road, also around the top road, and also around the top road. Once we've got to B, we have 4 different ways of getting back to A. It's either top and top, or it's top and bottom, bottom and top road, or bottom road and bottom road. That'll give us 4 routes. And that's going in a clockwise direction. What we can do then is go in an anti-clockwise direction as well. And our first short set of routes, A to C, C to B, top roads, top, bottom, bottom, top, and bottom, bottom. And then in all 4 cases, we go from B back to A across the top road going in an anti-clockwise direction. And that gives us 8 possible routes altogether. Question number 14. Mbali has 3 number cards. She puts them next to each other to make 3-digit numbers. For example, 247. How many different 3-digit numbers can she make out of the 2, the 4, and the 7? So take them in turns. Start with the 2, and then we add the 4 and the 7. That's one possibility. Keep the 2 in front and swap the 7 and the 4 around. So we've got 2 options there. Now we start with the 4. And we do the 2 and the 7, and then we keep the 4 in front and we swap the 7 and 2 around. So we've got 4 altogether now. Finally, start with the 7, followed by the 2 and the 4, and then for our last one, keep the 7 in front and swap the 2 and the 4 around, and then you can see we have 6 possible ways of making 3-digit numbers. Question number 15. Which one of these numbers out of those 5 numbers is greater than 1/2? There's a couple of different ways we can do it. There's a really long way, there's a medium way, and there's a quicker way. Let's look at the long way first so that we know what these numbers are actually representing. If we're going to have 1/2, the fraction a half means we've got 2 pieces altogether to make up a whole, and we've got 1 of them. So let's shade in 1/2. For the number 2/5, we're going to divide it into 5 pieces. A quick note here, if you wanted to divide a circle into 5 pieces, if you know there's 60 minutes in an hour, then you know that if you divide 60 by 5 and you get 12 minutes, you can imagine a clock face being 12 minutes, 24 minutes, 36 minutes, 48 minutes, and then you back up at the top. Anyway, let's shade in those 2 pieces for the 2/5. And you can see 2/5 is not greater than 1/2, it's less than. We'll do the same thing for 4/7. Same idea with the clock to divide it into 7 pieces, and we need to shade in 4 of the pieces. 1, 2, 3, 4. Okay, that one looks like it's greater than 1/2. Let's do the 9ths. 4 9ths, we're going to shade in 4 of them. 1, 2, 3, 4. That's definitely less than 1/2. The 11ths. 1, 2, 3, 4, 5 11ths. Also less than 1/2. You can see it doesn't get to the halfway point. And finally, 13ths. Let's shade in 6 of those. 1, 2, 3, 4, 5, 6. Also doesn't make it halfway. So doing the shading system, we can see that only 4/7 is greater than a half. In the test, we can be stuck for time, so let's look at a quicker way using a calculator. First of all, we'll take the half and see what it is as a decimal fraction. Decimal fractions are another way of representing fractions, but we don't have a number on top and a denominator. We have a whole number, a decimal point or a comma, and a fraction which is represented by all the digits off to the right. 1/2 is equal to 0.5. 2/5, 2 divided by 5, is 0,4. So we can see that one is straight away, that's less than a half. 4 divided by 7, we get the same 0.5 as we got for a half, but whereas the half was all zeros after that, the 4 divided by 7 is 0.57142885. It's bigger than a half. 4 divided by 9, 0.44444, clearly less than 0.5. Then we have 5/11ths, 0.454545, also clearly less than a half, less than 0.5 to start off with. And the 6/13ths, 0.46153884, and the same pattern repeats, but it's also less than 0.5. So when you're comparing it, if you look at the first two digits after the decimal point and compare it to the 0.50 here, you'll see that only the 0.57, which was the 4/7, that one, turned out to be greater than a half. One final method, if we change each of the given fractions, each of these and that one, to equivalent fractions. An equivalent fraction is just using different digits to represent the same amount. If we take the 2/5 and we double it, we can change it into 4/10. And if we take the 4/7, it becomes 8/14, 4/9 becomes 8/18, 5/11 become 10/22, and 6/13 becomes 12/26, 12/26. Now, to compare each one to a half, we're going to have to change the half into an equivalent fraction. 1/2, if we look at comparing tenths, we need to change it to 5/10. You can see that 5 is half of 10. This is the equivalent fraction for a half. And the very first one, 4/10, definitely smaller than 5/10. Then on the second number, 1/2 is 7/14 in the red block. And 7/14, you can see it's smaller than 8/14, which came from 4/7. So this one is definitely larger than the equivalent 1/2. 4/9 turns into 8/18, definitely smaller than a half. 10/22, smaller than 11/22, which is the equivalent fraction of a half. And finally, equivalent fraction for a half in 26 is 13, and 12/26 is smaller than 13/26. So again, this one is the only number that's larger than a half.